In the last class, we worked out that capacitor will take up half dissipated in the form of heat. So यही बात ये है कि during the charges, during the charging process, electrons will be removed from onto the opposite. Hence, each plate acquires equal and opposite charges. Zero. Net charge as in all the positives cancel out with all the negatives, right? Equal and opposite charges. However, work is done by the battery in making the charges flow through the circuit. This work then gets converted into electrical energy across the capacitor, and based on the above working, it can be showed that conversion of chemical energy into electrical energy is not a 100% efficient process. The difference between the two values is dissipated in the form of heat as charged particles flow through the connecting wires, right? So expression for calculating change in electrical energy, basically how much additional energy a capacitor stores as its voltage rises from small to large. Let's say you have a capacitor of capacitance 20 microfarad and the battery was increased from 10 volts to 15 volts, right? You are asked about the change in energy, your E final minus E initial is equals to half CV squared minus half CV initial squared. Technically speaking, the capacitance stays constant and your V2 squared minus V1 squared. This is the formula for your change in electrical energy. This formula will tell you the additional amount of energy that is stored by the capacitor during charging. During discharging, let's say the battery was changed from 15 to 10 volts. Again, the same formula is used, but the energy will now be dissipated during discharging. So the voltage of the capacitance against time is a curved, right? Let's say you are given that the first second the capacitor dissipates 0.8 joules, right? From the graph you provided this value. Use the graph to calculate its capacitance. You have delta E is equal to half C V2 squared minus V1 squared, right? The change in energy for the first second was, initially you were told that the first second the capacitor dissipates 0.8 joules. However, if I work off from the graph, the capacitor stores 5 volts, right? And that is how I can work off the value of the capacitance. Next comes in properties of capacitors in series and parallel. During a series combination, please understand that the combined capacitance formula would be 1 upon C1 plus 1 upon C2 plus 1 upon C3. This is C total, right? So here it is. So here it is. Properties of capacitors in series. In a series combination, all capacitors get charged by the same amount, right? Because your voltage gets divided. According to Q is equal to CV, if charge is constant, then capacitance and voltage are inversely proportional. So energy in a series combination is directly proportional to its voltage. Total or combined capacitance can be worked out using the formula Q upon C1. Like voltages, individual voltages are being divided, right? They all get added together because in a series combination, you know from O levels that voltage gets divided. There's a specific amount of drop here. and the third one, right? So the one having a greater share of voltage will have a smaller value. Okay, so the point is that if voltage is being divided, right, you have the formula Q is equals to CV, and from here you can work out that Q upon C can be replaced in place of V, right? Voltage becomes inversely proportional to the capacitance. So the one having a greater voltage will have a lower value of capacitance, simply because charge is constant across each plate. From here you can work off Q being common gets cancelled off, and your relationship 1 upon C total.
Sir, your voice is not clear.
I'm saying, all I'm saying is, in a series circuit, the voltage gets divided. You can hear me, right?
Yes.
Okay. So this simply means that the charge, the charge on each capacitor is constant. So according to Q is equals to CV, if your charge is constant, right? This simply means you could consider charge as a value 1, and this would mean that voltage is inversely proportional to the capacitance. So the one having a greater voltage will have a lower value of capacitance. Also from Q is equals to CV, you substituted voltage as Q upon C. So if you had to calculate the total capacitance, the charge stayed constant, right? All these Q's cancelled off with the one on the left hand side, thereby giving you the equation 1 upon C total is equals to 1 upon C1 plus 1 upon C2 plus 1 upon C3, right? In parallel ones, the capacitance will add off because charges are different across each and every capacitor. So in a parallel capacitor, each capacitor gets the same voltage, right? This is from O levels. Since V is constant, therefore, according to Q is equals to CV, V being constant, Q is directly proportional to the capacitance, right? The energy stored by any capacitor is directly proportional to its charge, and the total combined capacitance can be worked out as follows. Your total charge is equals to charge on each capacitor. Thereby, according to Q is equals to CV, your V is constant. In place of Q, you just simply substituted C1V, C2V. All the V's cancel off and you get a relationship 1 upon C total is equals to, C total is equals to C1 plus C2. This simply means that the more capacitance that can be stored, the more energy can be produced, thereby fulfilling the purpose of a capacitor. Capacitors, by the way, are energy storing devices, right? So preference is given to parallel capacitors because you get more energy content. Secondly, if one of the capacitor dies off in a series circuit, the entire circuit will stop working. Let's say I have two capacitors in series and two capacitors in parallel, right? These are connected to a battery of 10 volts. So the total combined capacitance would be 1 upon C is equal to 1 upon 20 plus 1 upon 20, which becomes 1 upon 10 for 1 upon C. So you reciprocate it and you get combined capacitance as 10 microfarads. E is equals to CV squared, you have the capacitance, you convert it into farads by multiplying it by 10 to the power of minus 6. You have the voltage, right? You simply get the energy value 0.5 millijoules. If you calculate, you'll understand, right? You have in front of you, right? The combined capacitance will add up. 20 plus 20 becomes 40 microfarad. The same battery is 10 volts. There's half CV squared. You square the value 10. You convert the farad value, uh, the microfarad value into farads, and you'll understand that the energy stored is 2 millijoules. If you were to compare this circuit with this, don't you think the parallel one stored 4 times the amount of energy as compared to a series circuit? Right? This is the reason why parallel circuit is preferred over a series circuit. Right? If the battery is not given, you will simply judge by checking out one plate of the capacitor to another plate. Like they will tell you, if positive is connected to a positive and negative connected to a negative, then this becomes a parallel capacitor. If positive is connected to negative, then and negative is connected to positive, that is a series circuit. They will definitely give you the sign. Concept of safe working voltage. Safe working voltage is basically the maximum amount of voltage that a capacitor can work efficiently on. Right? By the way, please realize that the dielectric simply means that the space between the capacitor is termed as a dielectric, meaning to say there are two different types of charges between the two. Right? So let's say you have A, B terminal having 12 volts. There's 30 microfarad, 30 microfarad. Both of them have the same amount of capacitance, so your value gets distributed evenly. Right? Let's say you have two capacitors, 30 microfarad, 30 microfarad, and the maximum voltage that you were providing was 6 volts. So 6 volts gets dropped here, 6 volts gets dropped here. Right? Moving forward, let's say I have 9 volts here. Now, in 9 volts, first of all, you will reduce the parallel circuit. 30 plus 30 makes it 60 microfarads, right? And the 30 becomes, the 30 comes in series with the 60 microfarad, right? Please check 1:2 ratio hai capacitance ka. In a series circuit, capacitance is inversely proportional to the voltage value, and this is the reason why the voltage drop would be 2:1. So if you check 2 upon 3 total share of the voltage into 9, you will get a value of 6 volts for this capacitor and 3 for the other one. Now again repeat kar raha hu. Let's say I have a circuit of capacitors. All of these are 30 microfarads. ये पैरेलल ऐड हो जाएगा 30 30 30 30 120 बन जाएगा. ये वाला 30 हो गया, ये वाला जो है ये हो जाएगा 30 plus 30 60 और ये वाला हो जाएगा 30 microfarad. Now this is reduced to a series circuit. Please understand that capacitance ratio is 1:2 1:4. So your voltage ratio would be inverse. The one having the share of the maximum share of capacitance would have the least share of voltage, whereas the one having the least share of capacitance will have the maximum share of voltage, right? And then you can work off the entire thing. Let's say you want it for this, so
Why did we multiply it with 16.5?
calculator se check kar lena. 16.5 is the total voltage of the battery. the battery voltage. मुझे चेक करना है यार कि इस वाले जो ब्लू हाईलाइटेड पार्ट है इस पे वोल्टेज ड्रॉप कितना है. तो 4 वाज द शेयर, 11 वाज द टोटल रेशियो. आई मल्टीप्लाइड दैट बाय 16.5 जो कि मेरी बैटरी वैल्यू थी.
6.
During the first 4 seconds, the charging process a charge of 22 microcoulomb will flow through the circuit. Use this information to calculate the value of the resistor R. Please understand that Q is equal to CV. Your charge is provided 22 microcoulombs. Your voltage value needs to be found out because you have just consumed 4 seconds of the charging process. Right? You are provided with the capacitance, which is 4700 microfarad. You will realize that during this process, the capacitor stores 4.7 volts. If the capacitor is storing 4.7 volts and it is in series with the resistor, the rest of the voltage goes to the resistor. So during this process, the resistor has 4.3 volts. Q is equals to IT would provide me with the value of the current. I have the time. The current comes out to be 5.5 amperes according to V is equals to IR. There was 4.3 volts being dropped. Current was 5.5 into 10 to the power of -3 और यहाँ से मैंने resistance निकाली which is approximately 780 ohms. आपसे next part पे कह रहा है suggest what happens to the voltage of the capacitor and voltage of the resistor if the circuit remains switched on for a long period of time. Initially, when the time was 0, meaning to say you had just started off your circuit, the resistor would consume all of the voltage, whereas the capacitor takes time to charge. So there was 0 volts. As time proceeded, the capacitor started to charge, whereas we worked out from the calculation that the resistor had 4.3 volts. Finally, all of the voltage is consumed by the capacitor during its charging, whereas the resistor then has to give up its voltage drop. So simply your graph would somewhat be a curve. If there was no resistance, the time taken to charge the capacitor would have been comparatively lesser. We are assuming that the capacitor gets fully charged and consumes the entire voltage. So you are asked to calculate the final charge stored by the capacitor. The capacitor was 4700 microfarad. You convert it into farads. Your voltage value was 9. This is the final charge stored by the capacitor. Expression for calculating the capacitance of a hollow sphere. Now this is from electrostatics. You know for a fact that the potential is Q upon 4 pi E naught R. Right? You are asked the capacitance. You have a formula Q is equals to CD. Right? In place of V, you can substitute this expression Q upon 4 pi E naught R. Your Q gets cancelled off with Q, and you can simply work out that the capacitance is equal to 4 pi E naught R. This simply means that for a charged sphere, its capacitance is directly proportional to its radius. How to charge a secondary capacitor using an already charged capacitor? Let's say I am charging a capacitor which is 20 microfarads. Calculate the charge stored. Q is equal to CV. You worked out 200 microcoulombs. Calculate the energy stored. E is equal to half CV squared. The capacitor was 20 microfarad. Voltage was 10 volts. You worked out 1 millijoule of energy was being stored during this entire process. Now the battery is removed and capacitor A is connected in parallel with an uncharged capacitor B of value 80 microfarads as shown. 80 microfarads. 80 microfarads is 1 millijoule. 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 right? This capacitor was charged, right? It's parallel, so the voltage remains constant. Again, Q is equals to CV. The charge is directly proportional to the capacitance because in parallel circuit, voltage is constant. 20 microfarad to 80 microfarad is 1:4 ratio for the capacitance. Therefore, your capacitance, your total charge was 200 microcoulombs, right? Your charge is directly proportional to the capacitance. Since it was in 1:4 ratio, the charge gets divided in 1:4 ratio.